Hi everyone, I am Bhagyalakshmi, Department of Mathematics. Today we are going to discuss about the continuation of the stretching of an elastic membrane. So already in this sum we derived the lambda values as 2 and 8 for the, and also find the corresponding eigenvectors. For lambda equal to 2, corresponding eigenvector is 1 and minus 1, and lambda equal to 8, the corresponding eigenvector is 1 1. We derived up to this. So in this video we are continuing with this. So for the elastic membrane we want to calculate the theta value, where it is in which degree it will be. So we know the formula for cos alpha equal to x divided by square root of x square plus y square, and y divided by square root of x square plus y square. So in this, for each and every value separately we can calculate. So x1 equal to 1 minus 1 and 1. You can choose these two values. So this is x value and this is y value. Each value we can substitute in this equation. So minus 1 divided by square root of x minus 1 the whole square plus 1 square, that is cos inverse of the cos of minus 1 by root 2 we get. So take this cos to the right side, and it becomes cos inverse. So the alpha value we got. So 1 minus alpha cos inverse of minus 1 by divided by root 2. So the value comes under the quadrant 4. So it is the alpha value is, from this alpha value is 135. Next we can choose the x2 value. x2 is 1 1, and this implies the same procedure if we follow, that is x value is 1 and y value is 1. If we substitute in this equation we get the cos inverse of alpha equal to alpha equal to cos inverse of 1 divided by root of 1 square plus 1 square, that is alpha equal to cos inverse of 1 by root 2. So cos inverse of 1 by root 2 comes under the quadrant 1. So alpha value is 45. So from this this way we can calculate these two theta values. Next, the polar coordinates for the deformation we want to calculate. So the polar formation is, before that we want to calculate the principal direction. So the principal direction occurs only in the 45 degree and 135 degree, just we calculated. So after this the vectors make 45 degree and 135 degree angles with a positive x1 direction. They give the principal directions. The eigenvalues show that the principal directions, the membrane is stretched by the factors 8 and 2 respectively. Now let us choose the principal directions as directions of new Cartesian coordinates system u1 and u2, with the positive u1 semi-axis in the first quadrant and the positive u2 semi-axis in the second quadrant of x1 and x2 system. Let us consider the u1 equal to, that is the x value, y value only we are considering here, that is a cos theta, x equal to a cos theta and y equal to b sin theta. In this we take these two as a boundary point of the unstretched circular membrane as coordinates cos theta and sin theta. Hereafter the stretch will we have, so instead of this x and y, replace these values, and the a value is, for the first a value is 2 and the second a value is 8. So we got this equation. From this cos theta value equal to x by 2 and sin theta value is y by 2. So we know that the sin square theta plus cos square theta equal to 1. So in this equation we can replace all those values. So the sin square cos theta sin theta value and cos theta value, sin square x by 2 the whole square plus y by 8 the whole square, which is equal to 1. So that is the squaring on both sides, x square divided by 2 square plus y square divided by 8 square equal to 1. That is x squared by a square plus y squared by b square, which is equal to 1. It is like a elliptic equation. So the given the equation is deformed boundary is an ellipse. So the given diagram, so check this diagram for this one. In this 4 directions the 45 degree angle is framed here in the first quadrant, and then the 135 is framed here with this second degree value. So this is a way to calculate the stretching, and how what is the shape of this stretching is, that is why it is an ellipse for this sum. Thank you.